But today we're doing emotion, and Thursday we'll finish emotion. So today is sort of setting up what emotion is. And then Thursday, I have a ton of videos because it's such a rich set of neurological and neuroscience things related to emotions. We're just going to set up today. If you've had a class where emotion was focused on, then some of this stuff will be review. But I do want to set it up because it's important, because emotion is a very difficult concept. It's not as difficult as consciousness, let's say. But it is one of those things that make you pause and think. And before we go on to this stuff, I chose this comic yesterday to start with because I think it has a lot to do with what we're doing right now, and how we are biased in our emotional energy and our emotional spheres, let's say. Okay. Right, so the human brain has a simple equation for emotional reactions. E, emotional power of an event. C, your distance from that event. P, the strength of your emotional reaction. E divided by C equals P. Okay, pretty simple, right? I am streaming for my students and for the internet in general. That's why I'm doing it on Twitch, because it's public. But you do have to follow me to participate in chat. So both. Vegan, 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 vegan. Thanks for letting me know that you're a vegan. Deep down, we all recognize this. But it sounds really weird when you verbalize it. Well, there was that earthquake that destroyed New York, but I realized I have leftover Chinese food. So I'm feeling pretty good. Okay. We have this reaction to coronavirus these days, right? And any feeling that you feel right now is valid. I don't want anybody to take that away from you. Okay? Any feeling that you have right now is valid. So if you are a senior and you are graduating this semester, I feel terrible for you. And you are allowed to feel upset by that. You are allowed to feel bummed by that. You are allowed to grieve the missed opportunities, the missed experiences, and all of that stuff, right? And that's very egocentric. It's very egocentric. And I don't use egocentric as pejorative, or I don't use it pejoratively there. It is. It's about me. If somebody says that's selfish, you tell them, well, most of our emotional reactions are selfish. I'm sorry. That's just the truth of it. Yes, my emotional reactions are selfish. Most of the time. But we do obviously have emotional reactions for other people. We have emotions that are others focused. But distance does play a role in that emotional reaction. Okay, so, feel your feelings. You are validated in those feelings. I validate your feelings. Okay. Mourn for your life and mourn for the others. Be upset when people don't social distance. Get in people's faces. Not really, though. Tell people that you please respect my space, which is now a 6 feet radius. Okay? Respect my space. Social distancing. Stay the F home, right? Should probably... There we go. So... what is emotion? This is a very difficult question to answer. Yes, it's a difficult question to ask, too. What is emotion? So, how do you feel right now? That's my question for all of you in chat. How do you feel right now? Give it a word. Or a few. Give it a word or 2 or 3 or 8. Stressed, tired, anxious, tired, groggy but good, Tired, but coffee helps. Indeed it does. Indeed it do. Stressed and conflicted. Okay. Anxious. Distracted. Okay. Let me ask you another way. Because I can ask this question in two ways, subtly changing the meaning of feel. How do you feel? See, I slightly changed my intonation on feel. So how do you feel? Dr. Swan, it's too early for this. Too early for those questions. That was a question for 3 weeks ago when we were talking about consciousness. Don't worry. How do you feel? Well, like, I have receptors in my skin, and they let me feel. So my next question to you all is, how do you know what you are feeling? Let me know in chat. How do you know what you are feeling? What do you do to find out how you're feeling? Waiting for them responses. Come on now. How do you know what you're feeling? Come on. You can do it. I know you can do it. Physical responses. Okay. Physical responses to the feelings. Think back to other times I felt this way and put a name to my current feeling. Okay. I read a large number of books to expand my vocabulary so that I better articulate how I feel. Okay. When I try to work on stuff, it just overwhelms me way too easily. Julia, shrug. I don't know what you mean by shrug. Carrie, examine my reaction to things. Okay. Wanting to go back to sleep. I don't know if that answers the question. My reaction to a feeling. Okay. Alright, fair enough, Julia. Alright, my last question. My last philosophical question. What determines how you are feeling? What determines? What are the things that indicate to you how you're feeling? Physical things. Okay. Where do you get the feelings from? Environment. Okay. Situation. It's happening around me. Okay. There's 3 answers of the same in the same vein. Okay. I like the convergence of that. Okay. Life events. Environment, people around me. Okay. Internal stresses or lack thereof. Okay. Environment and situations. Okay. What about internal stuff? People who said environment, situation. What about internal stuff? Social constructs. I like it, Carrie. I like it. What about internal stuff, though? Right? We can feel things from the way that our body behaves, right? Serotonin, indeed. And dopamine. Yeah. Right, so for those of you who maybe struggle with anxiety, that's all internal. Most of the time, anxiety comes from creating stressors that aren't actually there, right? So, you know, illness can bring emotions you don't want. Yeah, for sure, Tasty dude. Yeah. So, we're going to start off historical here. And then probably that's going to be the nature of this day. And like I said, on Thursday, we'll move on. Okay. Yeah, exercise is definitely part of it. So, early concepts. So, I want to introduce you to two names. James Papez, and then Paul MacLean, who followed James Papez. So, early on, James Papez, I'm not entirely sure how you pronounce it. I'm just gonna say Papez, and apologies if I am incorrect. He determined that through various methods that the hypothalamus, the anterior thalamus, so the front part of the thalamus, the cingulate gyrus, which sits on top of the thalamus, as I've pointed out many times. Does anybody remember what I said about the cingulate gyrus and me? Let me know in chat. And the hippocampus are all indicated in emotional processing, okay? And we will jump to those ideas again, okay? We will jump to those ideas again. Yes, Katie, that was my favorite part of that's my favorite part of the brain. And the reason why it is because dissertation work that I did. I had to talk about it all the time. Yeah. Never want to do that stuff again. Anyway, still favorite part of the brain. Following up James Papez is the other guy that I mentioned, Paul MacLean. Okay, pronounced the same way as McLean County, Illinois. Okay, McLean. He followed up on Papez's work. Okay, and he said that this idea of those places, those ideas are all connected. So, hypothalamus, anterior thalamus, cingulate gyrus, and hippocampus is the Papez circuit. Okay? But he also said, but there's another structure attached to the hippocampus that's really important. And we're actually going to spend a lot of time on this discovered piece of the basal ganglia, which is the amygdala. Okay? So not only is the Papez circuit, these structures here, but the amygdala. And then, because the amygdala is so important, it has connections to another cortex. Okay, so these are all limbic system brain pieces, part of the basal ganglia and other limbic system structures, internal structures housed within the cortex, right? I'll show you a piece of the cortex here in just a second. But the amygdala is also very, very important. And again, like I said, we're going to spend a lot of time with the amygdala, and then we'll jump into the orbitofrontal cortex, which is one piece of the cortex, which is extremely important. Extremely important for, it's just like making good emotional decisions. Making decisions based on emotional reactions, right? And so the concepts that we're going to focus on Thursday have to do with the thalamus and its connection to the thalamus, okay? So the thalamus, that big old thing of the diencephalon here. the diencephalon here, right? A big old diencephalon, this whole thing right here. Thalamus sits on top of that, right? So the anterior thalamus is this structure right here, okay? Coming off of that structure is the hippocampus and the fornix, right? So we have the hippocampus. We'll talk a little bit about that, but we spent a lot of time talking about the hippocampus last week when we were talking about memory. And sitting at the edge of the hippocampus is the amygdala, okay? Plural of amygdala, because you do have two, is amygdalae, okay? Amygdalae. So essentially all you do is add an E to the end of this. So amygdala E, and it makes that amygdalae, okay? Because you have two of them, because this is a three-dimensional structure, and so you have one in each, essentially one in each hemisphere, right? And so sitting above the thalamus here is, so that's the part of the ventricle, okay? This is the corpus callosum, which we've talked about extensively. And then sitting above that is the cingulate gyrus, right? So the ACC is technically my favorite part of the brain, which is the anterior cingulate gyrus. That's this part here. But it's the whole thing. It's stuff that you can see how it connects then to the hypothalamus and the amygdala, and then you have the orbital or orbitofrontal cortex. Okay. And so what I'm going to, and so these are all brain areas. Okay. These are all brain areas. I've bolded the ones that we're going to spend the most time talking about. The thalamus, which is basically going to be the foundational thing across all of our discussions, because it's the sensory switching area. It's where all of your sensory information goes to, except maybe for your olfactory system. But everything else goes to your thalamus. So it's the foundational brain structure, because most of the things that we respond to, as you indicated in chat, were having to do with responding to environmental stimuli, and that was a heavy focus of the book chapter on emotion. Is just like, okay, and that's where a lot of early theory came from, is how we respond to emotional stimuli from the environment, right? How do we respond to stimuli in the environment in an emotional way, as opposed to a directive way, or a rational way, or a utilitarian way, right? It's all emotion. Then again, we're going to spend a lot of time talking about the amygdala, okay? And then I have some research to share with you regarding the orbitofrontal cortex and regrets, or the inability to make emotional decisions if it's missing, or if there's some damage there. So those are the three that we're going to focus on specifically. To change gears, though, so that's just an overview of how this today and Thursday are going to go. So what I want to first start out with is the historical evolution of emotion theory, okay? And again, if you've had a class with me, maybe, or if you've had some other psych class where emotion is discussed, then you probably have heard some of these concepts before. Even in health psychology, the semester some of you are in, we've talked about some emotion theories with regard to stress, right? So historically, one of the first offerings of emotion, and specifically emotion generation, where emotions come from in response to environmental stimuli, comes from William James and a contemporary of his who developed a similar theory at the same time, but across the Atlantic Ocean over in France, Lange. Okay, so it became the James-Lange theory of emotion. Okay. I don't know why they didn't put the accent over the E here, but I like how Gazzaniga and I guess the makers of the book images put the people of the theory in the actual scenario. All right. So how this theory works is you see a bear. Okay. You see a bear. Okay. Bear in red to signify some danger. Sure. Yeah. So pop it out from the rest of the text. Okay. You have a conscious perception of the stimulus. The bear, you see a bear, you know it's a bear. It's a bear. Shouldn't be near a bear. I don't want to be near a bear. Bears I heard are dangerous. Why would I want a bear? No bears. Bears can maul you and eat your head off because they are scary. And even the guy who hung out with bears got killed by a bear. So bears. Or if we replace bear with tiger, and if you're watching Tiger King, that bee Carol Baskin down in Florida, okay, she's the one, okay, she's the one who made the tiger come after us. She's not really a bee. Anyways, so we perceive the stimulus, okay. The first thing that James-Lange said was that we have a physiological response once we recognize the stimulus. So you get the adrenaline, you get the epinephrine, which causes increased heart and respiratory rates, sweating, and ready to fight or flight, right? And followed immediately by the behavioral response, which is, I'm going to do the flight part, and I'm going to run away. Run away! Right? Epinephrine and adrenaline are the same thing, Tasty do. Adrenaline's used in the UK, epinephrine's used in the United States. After you run, after you do the flight, then you have the cognition. I am scared. My heart is beating fast. And I am running. I must be afraid. Okay? I must be afraid. Because of those things. Okay? Then the emotion is, I'm afraid. So we have the physiological response in blue, the behavioral response in orange, pastel orange, and then we have the subjective emotional in pink, pastel pink. Okay? So, the order of operations here is physiological response comes first, then the behavioral response is indicated by that second, and then the emotional subjective response is due to what the other two are indicating to you. So that's the James-Lange theory of emotion. We feel things because of how we behaved and how we physiologically responded. Now, this works okay with things like fear. This works okay. It has a very good explanation for fear. But Walter Cannon and his graduate student Bard were like, it doesn't explain other things, though. We can use fear to describe mostly everything. And so we'll keep that fear example, but it doesn't work for things like surprise, happiness, disgust, and sadness. And so they're like, there must be a concurrent response from stimuli in the environment. Okay? There must be a concurrent emotional cognitive response. And so they developed this. So this is called the Cannon-Bard theory of emotion. Okay? Cannon-Bard. Mostly his graduate student came up with it. But, Walter Cannon gets the credit. That's how grad student life is, though, unfortunately. Or it was back in the day. So, Cannon and Bard see the bear, or the tiger, right? Their thalamus gets that information because sensory input from the eyes goes to the thalamus, as we've talked about extensively, okay? That sends information to two places simultaneously. Simultaneously. The thalamus sends the information to the cortex, the occipital areas, to get processed as visual stimuli, okay? Which then cascades to the what and where pathways that we discussed earlier in the semester, okay? The what and where pathways. It's a bear. I don't like bears. Where is it? Can I run away from it? Okay? All of these cortex-driven computations. And at the same time, the hypothalamus says, sympathetic nervous system, you're on. Sympathetic nervous system engages the physiological fight or flight responses, and then, of course, the behavioral response is running away. Unless you fancy yourself a bear fighter. Okay? These are simultaneous. That's why they branch off here. Don't be confused. That's why they branch off here. Don't be confused that this happens right here versus these happening lower in the image. That obviously they couldn't. Well, I guess they could have done it where this is. You know, in line. This is essentially happening at the same time these two are happening. Okay, so this is happening at the same time this is happening. So I'm scared, and at the same time I have a physiological response to fight or flight, sympathetic nervous system activation. Okay? This is actually fairly quick. According to Cannon and Bard, your cortex receives the information extremely quickly. I am scared, so therefore I am going to activate my fight or flight response. Okay? So this is together. These two things happen together. Now, following up from Cannon and Bard, which is fine, it works quite a bit. Okay? It works quite a bit. Richard Lazarus said, we also have to do this appraisal. And there are two stages of appraisal. Okay, there's an initial appraisal, and then there's a secondary appraisal. So initial appraisal or primary appraisal, and then a secondary appraisal. Okay. So Lazarus sees that bear, and he says, well,
Daddy, what's wrong with your voice?
What's wrong with my voice? Nothing. Ollie said I was talking funny? Well, I can help you on that one.
Mommy, I want to see Daddy.
So, the first initial, I can't help you right now, baby.
Mommy, open the gate.
Move the gate up so she can't come down herself. Anyways, so Lazarus sees the bear. Okay, the primary appraisal, you can see there's no pastel blue on here. There's no physiological response that's necessary, okay, in Lazarus's model, okay? So, Lazarus says, all right, I see a bear. I need to make a quick cost-benefit analysis. I've got a bear coming toward me. I need to do one of two things, okay? Risk is high. There's no foreseeable benefit, unless I really love bears, okay? And then I'm gonna figure it out. Wait, that's a bear with teeth and I'm scared. That's the emotional response. No physiological response necessary, according to Lazarus, although there is obviously going to be a physiological response because you need to run. So, implied here in the behavioral response is that pastel blue physiological response. Okay. So yeah, Tasty Do is kind of like sizing up. But it's actually really quick. It's instant cost-benefit analysis. Okay. Once you do that primary appraisal, whatever appraisal is, positive or negative, there's a valence associated with it, positive or negative. That's going to indicate what then the pastel pink emotion is going to be. Okay, so am I scared? Am I happy? Am I glad that this bear is coming toward me? I love bears. Okay, I love bears. Bears are amazing. Okay, so I'm going to be like, ooh, that's a bear! Amazing! Or negative. oh crap, I'm in danger. I gotta get the crap out of here. And so we have the I'm scared part. Okay. And then you run away. Or Lazarus runs away. Okay. That's a good question, Tasty Do, about Lazarus theory, physiological response. He actually didn't include a physiological response in his theory because at the time, because the next folks that we're going to talk about, at the time, so concurrently with the next folks, it was determined. Cannon Bard also did this in the 1930s. They said this in the 1930s. That autonomic responses, sympathetic nervous system responses, are diffuse and can apply to pretty much any sympathetic activation. It doesn't necessarily have to be fear that causes a fight or flight response. You can get the same flushing, heart rate increase, breathing rate increase, sweating, and other things when you're having sex, okay? Or when you're really, really, really happy. So the fact that it's diffuse, it lasts longer than the emotion, the emotional response. He didn't include it because it doesn't really matter here. It doesn't really matter. And so, yeah, you can learn to change the way that you respond to these situations if you are a bear trainer and you know, hang out with bears all the time. Or you're the Tiger King and you hang out with tigers all the time. Right? Yeah. If you're not watching Tiger King, then I'm not. Astrid is, though. Yeah. Yeah, pretty much I wouldn't say it's a moot point, but it's a superfluous point, okay? So. Alright, so I mentioned the folks that we're coming to next are contemporaries of Lazarus, okay? There's a new episode coming, Jesse. There's a new episode coming. So Schachter and Singer. Schachter's still alive, by the way. Daniel Schachter's still alive. He's older now. I think he's an emeritus professor of somewhere back east. Something like that. I don't know about Singer, though. I don't know if Singer's still alive. But they came up with a really important distinction about interpretation. Okay? Physiological response and interpretation. So the reason this is a contemporary with Lazarus, and the reason we can combine this, and how damn, Carol Baskin, I just saw your response, Gary. Yeah, man, that bee Carol Baskin down in Florida, it's her fault. So this, if we combine the outcome of Schachter and Singer with the outcome of the theory for Lazarus, we have a pretty good explanation for emotional generation. What makes and the sequencing of emotions. Okay. You can tell, though, that this ordering seems like james-lange. And that's actually the point. That's actually the point here. Okay? Because you can change the interpretation. But here's what's missing from this diagram. This diagram does not actually show the primary appraisal that occurs before the physiological response. Okay? What I want to do is combine Lazarus and Schachter and Singer, because this image doesn't actually capture Schachter and Singer's emotional lability theory all that well. So what I want you to do is, in your notes or however you're taking down this information, is I want you to add the primary appraisal that occurs before physiological response, but after seeing the bear. Okay? So I want you to insert it in here, right here. Okay? And the reason why we're doing this is because the primary appraisal does occur, as Canon and Bard indicated. You have the cognitive aspect co-occurring with the physiological response. And that cognitive aspect is the initial appraisal. Okay? As according to Lazarus. Okay? So the study that they did, and I'm just going to tell you the story of the study. You don't necessarily need to keep this, you don't need to write this down. It's a very cool study. Very cool study. So Schachter and Singer decided they wanted to test james-lange's theory in addition to Cannon and Bard and Lazarus, and pretty much see what they could do while focusing on the really important aspect of interpretation. There's a very small aspect of emotion that has to do with how do I respond to aspects in the environment. And so what they did was they had 3 groups. They had 3 groups come to the lab. One group was going to get an injection of epinephrine. So adrenaline, shot of adrenaline, low dose. Like, it wasn't the stuff that you would inject into a person if they're having like an anaphylactic shock, right? Somebody who's allergic to peanuts or something that carries an EpiPen with them. A lower dose than that, but it was going to increase their epinephrine effects. So like increased heart rate, breathing, sweating, pupils dilated, that sort of thing, right? So they were going to get injected with epinephrine, and they were going to be told the effects that they were going to expect, right? So they were going to be told they're going to get a rapid heart rate, they're going to get increased breathing, sweating, eyes dilated, they're going to feel flush, that sort of thing, right? Hot, all that. The second group got injected with epinephrine, but they were told that these are the side effects that you're going to anticipate. You're going to get a headache. You're going to feel lethargic. You're going to feel irritated, sleepy. All of the effects that are associated with the opposite of what epinephrine does in your body, right? And then the third group, which was a control, they didn't actually get injected with anything because they were just there for a baseline. So they were injected. They were given their sheet. Okay. They were given their side effect sheet. And then they were asked to wait in a room. In that room, they're like, okay, the second part of the study is going to occur momentarily. Please wait here and fill out this gigantic stack of questionnaires. And it was a very tedious and boring stack of questionnaires. Like, not useful information. They weren't actually recording most of the information. It was just a stack of papers for the participant to fill out. In the room was a Confederate, somebody who is in on it, who was told to act a specific way. I'll tell you how they were to act in just a second. And so they were in on it. But they were playing as another participant who was also waiting for the second phase of the study to begin. Okay? They were instructed to do one of 2 emotional outbursts. The first one is they were instructed, acting. They were instructed to act very silly and euphoric. Start dancing around and being like, oh, I'm so happy. I'm waiting for everything. This is amazing. Da-da-da-da, I'm doing a dance, doing a jig. Whee! Who needs to do these papers? Oh, it's amazing. Those sorts of responses. The second set of instructions that they were supposed to give, emotional reactions they were supposed to give, was that of like extreme agitation. Okay? Extreme agitation. They were angry and upset that they had to fill these things out. They were mad. They would pound on the table, bang on the table. They would stand on the table, stomp their feet, saying, "Why do we have to wait for this study? Why can't you guys be on time? What is taking so long?" Just like supreme anger and agitation. Okay? Then the second phase of this, and so there was a camera in there recording all of this. Okay? It was specifically trained on where they had the real participants sit. And they were just watching. They were watching what the participant would then do. If the participant would engage in that same behavior or not. Okay? So this was a 2x3 factorial study. So there were people who got the epinephrine, who sat with the euphoric confederate. There were people who got the epinephrine and told that it was epinephrine. Who sat with the angry person. There were participants who got the epinephrine and told the opposite. I don't know if the videos are. I don't know if the historical data is on YouTube. I know a lot of people have been putting it on. See if you can spot it. Or maybe there's somebody who's made a recreation. You can't really inject people with epinephrine these days, though. It's not gonna. It doesn't pass IRB muster these days. This happened in the 1960s. So, yeah. So, there was groups that then the epinephrine who were told the opposite effects were going to occur in the euphoric confederate condition, and then there were participants who got the epinephrine opposite effects sheet in the angry confederate condition, and then there were two control participants who didn't get injected with anything and sat with either the euphoric confederate or sat with the angry confederate. Now, the results are pretty straightforward. Asking the participants in the control condition what their response to the confederate was, and how they felt while they waited, was pretty self-explanatory. They were maybe a little annoyed by having to wait. Maybe saw that the ones in the angry confederate condition were a little like, maybe you should tone it down just a smidge, dude. And then the people that were in the control participants that were in the euphoric condition were thought maybe this person was a little silly. The point of the control condition, though, was to show that people were able to describe their own emotions readily and without any external influence. They had the emotions that they felt because of internal circumstances. The people who received the people that received the epinephrine and were told this is what the effects of epinephrine were not swayed by the either confederate conditions. They knew why they felt that way. It's because they received an injection of epinephrine. The real, and so that, again, internal circumstances. Again, the last bit is this group that was told that we're going to feel the opposite effects of epinephrine. But of course, they weren't actually going to feel the opposite effects of epinephrine, because epinephrine's going to do its thing regardless of what you're told it's going to do. It's going to do the increased heart rate, the rapid breathing, the eyes dilated, the sweating, the hot flashes, all of that stuff. It's going to do all of those things because that's what epinephrine does, regardless of what they told you it does. And because they were feeling that in either the angry or the euphoric condition, they actually said, I feel this way because I am angry, and I feel this way because I'm euphoric, depending on what condition they were in. They essentially interpreted their own emotional reaction to the epinephrine, not to the sheet of paper that they were told these are the side effects of epinephrine, but to the other person in the room. So yes, you can interpret your emotions based on your surroundings and other people around you, right? And so that's the heart of this theory, okay? So Schachter and Singer says you have an emotional reaction, then you run, and then you think about it. You have the interpretation, which is I'm scared. So this literally looks like james-lange. But that's not actually the point they were trying to make. The point they were trying to make is that we have internal sensors for our internal feelings, right? That's what the control conditions shows us, and that's what the informed epinephrine condition shows us. We have internal influencers and factors for our own emotional feelings. We don't necessarily need it. Okay, that's fine. But then we can get information from the environment that does change the way we feel, that potentially influence the way that we interpret those internal features. But it does have to include that initial interpretation of the physiological response, which is missing from this image. So I want you to add it to this image. It is missing that internal, that first appraisal, according to Lazarus, or the cognition that comes simultaneously with the physiological response, a la Canon Bard. Okay? So that's Schachter and Singer. Okay? That's Schachter and Singer. Now I have one more for you. Which it was included in this textbook because when Mike Gazzaniga wrote this textbook, he was already at UCSB, and the two people who are also at UCSB in the psych department, well, one person was in the psych department, the other one was in the anthropology department, were Lita Cosmides and John Tooby. They're a married couple, and they are famous for doing pretty much all of their work together. So Lita Cosmides is an evolutionary psychologist, a wonderful human being. And John Tooby is her husband, who is an anthropologist. He is a, not a physical anthropologist, but a, yeah, I guess he's a physical anthropologist, actually, now that I think about it. So they're a cultural anthropologist, but I don't think that's accurate. I think he's a physical anthropologist. And so he's in the anthropology department at UCSB. And Lita Cosmides is in the psych department, where I did my graduate work. And so they decided to come up with a theory of emotion generation from an evolutionary perspective, which is interesting, right? And it has a lot of branches. How you read this, by the way, is, so I broke up the image that's in your book. And so this line here goes to here. So you go ding, ding, ding. So 1, 2, 3, and then over here to this branch. Okay. It's a fairly complex set of responses. Okay. So Cosmides and Tooby see the bear. Okay. So Lita and John see the bear. They determine whether or not if it's the bear is stalking them and it's going to ambush them. It has evolutionary significance because if the bear is just minding its own business, we actually don't need to be afraid. If the bear doesn't see us, then we can go about our business. It's kind of like what your parents tell you about bees and, like, you know, don't swat at the bees. If you just let the bees do their thing, they won't sting you. Yada, yada, yada. It's a lie. Jerk bees. No, it's not a lie. But you get the point, right? So if the bear's not doing anything, then we can sort of go about our business. That means that we are in initial danger, because bears can actually run faster than us, and they, of course, are stronger than us. So we need to determine that, okay? If it's stalking or planning to ambush us, then fear gets turned on, okay? Fear emotion automatically activates this hardwired program that we're going to talk about on Thursday. And the reason they talk about this is because it's hardwired, because over generations and generations of similar situations in which that person was successfully either defeated the bear or ran away from the bear, they've procreated, so they've been successful. So this bear fear program that we're going to talk about from the amygdala is going to now direct all subprograms. And that's what these subprograms are. Bees are okay, Jesse. Wasps and yellow jackets can go get effed, though. Yeah. They can go die in a fire. emblazoned. Just immediately launch into flames wherever they are. Hopefully not in your house. These subprograms are all automatic, right? So first and foremost, I think the easiest one to recognize is a perception and attention shift. Our attention focuses on that on that bear and what that bear is doing, right? Leading to an ignoring of all other information. Rat studies, well, nothing proves, Jesse, nothing proves. Tisk, tisk, tisk. That fear is passed through generations. Yes. Well, not rat studies, but the evolutionary perspective is an argument for what we have as functions now had to evolve from previous generations. So that's the logical argument. Okay, that's a logical argument. You actually can't directly observe evolution. Unfortunately. It would take way too long. Unless somebody's watching us right now that can live generation upon generation longer than us. Then you could observe evolution, but we cannot observe evolution directly. We have to observe its effects. The subprogram goal and motivation change. Okay, so if you are enjoying a picnic in the woods, well, now you're not anymore. Okay, now you're not anymore. Information gathering subprogram jumps in. Okay, so we look for a tree to, instead of getting shade for our picnic, maybe run up it. Okay, so what we can do to then escape or fend or fight off. Okay, so those subprograms then change the way that we perceive objects and their intended functions or what their functions can be. Change 2. Okay. Our interpretation then go, does the bear see us? If not, then maybe we can be okay. Or in the way that this interpretation goes, did the bear see us? If no, freeze. Maybe it'll lumber on by. If yes, get the hell out of there and zigzag. Okay? Physiology changes, right? We need our eyes to get bigger. So eyes dilate. Our heart runs faster to get blood to where it needs to go. Our respiration increases to get oxygen where it needs to go. Our digestive system shuts down because who cares about digesting food right now? We don't need to go poop. Okay? All of these things change. Our physiology changes. That's a subprogram. Learning systems are activated. This is important. Learning systems are the thing that then keep this program, this main program, and all subprograms active into following generations if you are able to procreate because you are able to succeed, right? So we get this conditioned response. We'll talk about fear conditioning on Thursday, right? And then last, behavioral decisions then come about. This is all happening simultaneously, and they are all automatic according to Cosmides and Tooby in emotion generation. Now, it's a big bummer that these are all associated with fear, but most of this has been done with fear research, which is a bit of a bummer. Yeah, a bit of a bummer. What are you gonna do? There is far fewer research studies that attempt to explain all of these things with happiness, with arousal, sexual arousal, attraction, with sadness. Fear just seems to work. And the evolutionary idea about fear makes it seem like it works because we're observing the effects of evolution, as I just mentioned to Jesse. We're observing the effects of evolution. Fear works as the appropriate emotion to study because it's thousands of years of our existence. Right? Hey, Max. Welcome to the last little bit. All right. Before we end today, I do want to then talk about, so emotion generation is not the only field of research that emotion is focused on. A lot of emotion research has been on emotion production, and what then comes of facial expression. So I've said facial expression, emotion. So one of the key players in all of this is Duchenne. He said that there are true smiles, and I'm gonna play for you the "Can you spot the fake smile" video here in just a second. Okay. So a true smile, the lip corners get pulled up, and muscles around the eye, the orbicularis oculi, so these muscles around here, are contracted. So specifically, the corners of your mouth, look at that smile, and these muscles contract. In my case, my real smile makes me go very squinty, and people make fun of me all the time. Why do you make fun of me? I'm just smiling. Paul Ekman is another important name in this. Paul Ekman is probably one of the more famous emotion researchers, and he says that, and so he's done ethnography research with emotion. So he's gone to various cultures and asked them various things about emotional expression. And he's determined that there are universal human emotions: anger, fear, surprise, disgust, enjoyment, and sadness. Okay? So 6, sometimes there's 7. What is missing on this was 7. Interest is sometimes the 7th one, right? Which is slightly different from surprise. Interest. Sometimes they're 10, though. Sometimes they're 10. But Paul Ekman says that regardless of culture, and regardless of where that culture is in their development, okay, so he even went to tribes, low contact tribes out in Papua New Guinea, and some Amazonian tribes. So low contact tribes. These tribes, these indigenous peoples tend to live without modern luxuries. So they are very hunter-gatherer, nomadic, or Stone Age, not Information Age, right? No modern aspects to these cultures, right? But he would still go to them, and he would still and he would ask them, like, how would you make a what face would you make if your son died tomorrow? Right, that's a rough question to ask somebody, but like, what face would you make? And they would make a sad face, right? Typical to asking an American, if your son died tomorrow, what face would you make? That sort of thing. And so he found evidence for facial expressions, the same facial muscles making the same thing, making the same sort of face, right? And so the emotion is being felt in the same way based on facial expressions, okay? He also, which I think is actually pretty cool, like sub-finding from all his decades of facial expression emotion research, is this idea of leakage. So even if you're trying to hide an expression, there are going to be aspects of your face that won't be able to hide it at all. Which is why you end up with things like people saying that their face is a tell if they're like playing poker or whatever. They have a tell and it's in their face because they're trying to hide how amazing their 2 aces are when an ace drops on the flop, and then you've got 3 of a kind. We're like, oh yeah, and then another ace on the river, you know, and you're like, holy crap, I just won this pot, right? So that's leakage. You can try to hold it. And of course, leakage is an individual difference. People can be super non-expressive, or people can be like, I have way too much leakage, I can't contain my glee right now. So yeah, that's Ekman. Ekman's pretty prolific in the field of emotion. He's out at Stanford, I think. Yes. Yeah, Stanford, I think. And then Tracy and Matsumoto. Tracy and Matsumoto, they studied judo participants, so judo competition participants. And some of these judo competition participants were congenitally blind. And they found that even blind judo competition participants can show the same facial features of pride and shame as their sighted competitors. They've never seen it before. They've never seen pride or shame facial expressions, and yet do the same. So these are judo participants over in Japan, by the way. So these are judo participants in Japan, and so pride and shame are big parts of judo in Japan. Okay. All right. Can you spot the fake smile? It's just a cute little demonstration of it.
Take a look at these two photographs. One of them shows a genuine smile, the other shows a fake smile. See if you can spot the fake smile. Give yourself 1 point if you chose this photograph. Now try again with these photographs. Here's the correct answer. And finally, try to spot the fake smile here. If you scored 3 out of 3, then you're good at reading other people's expressions. 2 out of 3, and you're okay. And if you scored 1 or 0, then you might want to know the secret to spotting a fake smile. During a genuine smile, tiny crinkles appear around the sides of the eyes. During a fake smile, these crinkles are missing. So next time you want to know if someone's really happy to see you, simply look at the sides of their eyes.
Yep. So that's the orbicularis oculi. Orbicularis oculi. These muscles right here. Also the lips. So who was looking at the eyes and who was looking at lips? How'd you do on that? Let me know in chat. Okay. 2 out of 3 was looking at both, but mostly eyes. 2 out of 3 right. Okay. 3 out of 3 eyes. 3 out of 3. 2 out of 3. Okay. 3 out of 3. The eyes. Okay. Cameron, 2 out of 3. Alright. Not bad. Not bad. I would also say both. Look at both. The mouths really do a bad job at fake smiles. People strain to hold their mouths open, and so it kind of looks like a straining. So, yeah, real smiles definitely are wider, Julia. Definitely. All right, that's all we're gonna do for today. So thanks for everyone for coming